Good morning. Please welcome the director of the Morningside Academy for Design, John Oxendorf.
Good morning. Morning, everyone. Welcome to the Media Lab at MIT. This is a really exciting day we have in store for you. And it's the result of a big collaboration with a lot of different units at MIT, and especially with the Burgoyne Institute. So we're really excited to partner with them. And in particular, I want to highlight MIT Architecture, who's been a partner in developing this, and the MIT Press. And many of you know we have elements of design across all of MIT, and yet there's a lot more we can do to work together. And so by partnering with the Burgoyne Institute, we're really excited to bring the types of critical conversations, how we're going to tackle massive challenges on this spaceship Earth, and how we're going to bring people together from different disciplines to figure out how to get there. And I do want to just very quickly say thank you to the team from Burgoyne. We'd love to do more programs with you because you made it very easy, especially Nikolai, Stephanie, Haley, Tatiana, and we're joined by the president, Don Nakagawa. So if we could please thank the Burgoyne Institute team as well. Just a quick word about Morningside Academy for Design and what we're doing at MIT. Our acronym is MAD, and we're trying to be a disruptive as well as collaborative force for bringing together design voices. And so today's program really highlights exactly that. Please look us up at design.mit.edu. Follow what we're doing. If you see ways we can partner together, we'd love to work with you. And we've done a lot with the MIT Museum, the Media Lab, MIT Press, and MIT Architecture especially. So we're excited to keep doing this type of program in the future. And without further ado, I know you're all here to listen to our distinguished panels. And I'd like to invite our first panel and also the moderator, Benjamin Bratton. Many of you know Benjamin's director of the Antikythera at Burgoyne Institute, but also the best title ever, professor of philosophy of technology and speculative design. And I can't imagine anything more that we need right now at UC San Diego, of course. So please join me in welcoming Benjamin and our first panel, and let's have a great day. Thank you.
Hi, everyone. Thank you, John, very much for the gracious introduction, and thank you all for joining us here today. I know many of you came on Wednesday as well, and those of you who did know a lot more about the Antikythera program than maybe you had anticipated. Today is my chance to step aside in a way and let you meet some of the voices and thinkers and designers and makers who are really part of who make up the school of thought of the Antikythera program, and to let you, in essence, listen in to some of into the conversation that really constitutes the basis of the discourse. So I'm going to, just for those of you who weren't here on Wednesday, I'm going to do a little bit of a quick introduction to what Antikythera is about as a program, and then introduce the theme of today's event, Planetary, Sapience, and what we mean by that and what we think is at stake for this idea. I'll introduce our panelists, and then we'll begin. So again, this is sort of a moment in a week of activities here at MIT. To learn more about the program and all the things that we've been doing, you please go to antikythera.org or scan the QR code, and we'll take it away from there. As mentioned, we are very grateful, as John already mentioned, very grateful to our many supporters and collaborators in this ongoing initiative. So first, the name Antikythera, where does this come from? It is named after this little device, the Antikythera mechanism, apocryphally probably understood as the first computer. It was from the 2nd century BC, discovered in 1901. Took a long time to figure out what it was and how it worked because it was so anomalous in the evolution of technology as a kind of mechanism. Why it's important for us, not only is it because it was sort of a beginning point, but that it was not only a calculative device, it was also an astronomical device. It allowed you to sort of map and model the past, present, and future of celestial systems. And so the idea that at the very beginning of computation, there is this fundamental link between computation and cosmology, and how it is that intelligence locates and orients itself in relationship to this planetary condition, we take as a kind of foundational inspiration for not only what computation is, but indeed what it's for. A bit then quickly about the program itself. It is, as sort of intimated, a philosophy of technology program. It is also a speculative design program in one way or another, but I think increasingly it really might be thought of as more of a speculative engineering program. And the philosophy that we try to develop, uniquely I think a little bit within the academic discourse of philosophy of technology, is one that tries to engage and develop concepts from a direct relationship with emergent technological systems that in many ways perhaps have already outpaced the concepts and languages that we have to make sense of them, let alone how to orient them. So our team is large and vast and wonderful. We're here today, and so please say hello and thank you to them, and they'll all be very happy to continue to engage with you. Thanks also as well to our friends at the Berggruen Institute, many of whom are also here today as well. The real structure of the program, however, is the network of affiliate and studio researchers that we collaborate with very closely over the years. 2025, you see here, is open. I'll talk a little bit about that later on. So once again, you find out all you would like to know, a sort of essay version of the talk from Wednesday at our site. Very quickly, a little bit of the kind of design work that we do. A lot of this kind of cinematic vernacular is very important to the way in which we develop the work, not only how do we communicate it, but also how we investigate ideas in both an analytical and aesthetic structure. Planetary computation is really the core idea of the program, and in this it sort of means a few things. One is an understanding of computation at planetary scale, that global infrastructures are becoming increasingly not only computational but cognitive in their capacities, which we investigate through the lens of synthetic intelligence or AI, simulations, hemispherical stacks, which refers to the geopolitics of computation, and the theme of today's event, Planetary Sapience, which is in some respects the most philosophical of our initiatives. So the term Planetary Sapience was originally an essay in Noema, also published by Berggruen Institute a couple of years ago, which you can read. I'll introduce the idea, and I apologize as a writer. I sort of actually think through words, and so I prepared a short little text of introduction of this as well. And so if you'll indulge me, I'll present that to you in a moment. The real idea of this is how do we locate the artificialization of intelligence in the long-term evolutionary arc of the emergence of intelligence itself as a complex planetary phenomenon. One way to think about this is we say that we, the fire apes, have, in a very unlikely but precocious way, managed to figure out how to fold little bits of metal and wire and run electricity through it, such that the rocks are capable of feats of cognition that previously only primates had. This is part of the question that we are interested in. The dynamics of a kind of thinking about the evolution of technology and the evolution of biology, the evolution of intelligence as interrelated, commingling, nonlinear, scaffolding dynamics is one of the sort of the key frameworks that we are working with, a topic I went through in some detail in the lecture. Very quickly, some of the issues around understanding of computation is the fundamental dynamic of how it is that we are artificializing not only intelligence, but also life, also our sensory capacities, and all the things that, in fact, that make life, or not only in a process of being recomposed through a process of artificialization, but the computation itself is now the fundamental technology of this, which puts its status not only as an instrumental technology, but indeed as what we call an existential technology in some framing mechanism. Now the question, which will be sort of underlie perhaps in the background a lot of the discussions of today, is to what, in lieu of the various interlocking crises, climatic, planetary, and otherwise, in which our moment is situated, in what way is complex intelligence, especially through the dynamics of its artificialization, adaptive, and to what way it may in fact be ultimately self-extinguishing? The real question, as we say, is not necessarily is it or isn't it, but how might it be made adaptive? What constitutes the framework and preconditions for a viable planetarity, and how may complex evolution continue? The event here is also an opportunity for us to announce a collaboration with MIT Press, with our thanks to Amy Brand and Nick Lindsay and Noah Springer, who are here with us today. There will be an Antikythera book series with MIT Press. The first, you have a little preview of this. I'll let Blaise speak a little bit more about this. The first book on the series is called What is Intelligence? It will be published at the end of 2025 by Blaise Aguirre-Iarcas, who you'll meet a little bit later today. We have a preview of that, a wonderful little book called modestly entitled What is Life? That have a truly remarkable, James Goggin, also the designer of the book, is with us here today. That is on your seat with you. We also are developing a digital journal, which many of in fact, all of the participants of our two panels today are contributing to in various ways, and we'll show you, those of you who were on Wednesday saw all about that. These are the authors for the first issue of the journal, many of whom are here today. That first issue will be out in May. The preview, however, of the journal and some of the examples of how these articles and projects will be presented is already live at journal.antikythera.com. The journal articles are not only written by some of our key collaborators, they are themselves collaborations between these extraordinary thinkers and some of the most interesting digital designers of our time. Each is designed and composed as a bespoke and perhaps hopefully definitive example of the thinking that has gone into them. So our authors include people both living and non-living, some Turing and Vernadsky, obviously, as well as the really wonderful digital designers that we are continuing to work with, some of whom are here today, and so we're very glad to be able to work with them. Again, journal.antikythera.org is where you can see the preview of the whole initiative and ultimately where the project will be living. Last point of sort of introduction to the program before I turn to the Planetary Sapience itself is that Antikythera runs studios every year. One of the core aspects and structure of our program is the design studios that we run every year. The next studio will be held here at MIT in 2025, and we over in the early summer, and we look forward to opportunity perhaps to collaborate with some of you all. All right, so again, these are some of the relevant links for you to consider as you learn more about the program and hopefully find some ways to engage. And so with that, let me take a couple more minutes to just sort of set the agenda for today and the topic of Planetary Sapience before I introduce our esteemed panelists and we get underway. The question of Planetary Sapience really comes down to posing the question of what is and what may be and what must be the relationship between the planetary and intelligence itself. And where does planetary computation fit into this? The questions are equally philosophical and technological at the same time. The relationship between the two is one of, among other things, of disclosure and revealing. Over millions of years, intelligence has emerged from a planetary condition, which until quite recently, until it has been disclosed quite recently to intelligence through forms of technological perception, more opaque than it has been. the relationship is also one of composition. How do we, for the present and for the future, how can complex intelligence, both evolved and artificialized, conceive a more viable long-term coupling between the biosphere and the technosphere? So I'd like to then sort of just get right to it and begin our conversation with the panelists. But before doing so, to think a bit about, as a sort of getting a bit more granular with the agenda, some of the ways in which this is made so, and what ways in which this is made real. One of the things that you'll see in the course of the whole conversation around the Antikythera program is it's quite interdisciplinary. It is a synthetic initiative. And the disciplinary backgrounds of all of our participants attest to this, as do some of the ways in which we're framing the question of planetary sapience. One that is based not entirely and only on a kind of anthropomorphic vision of Earth, constituted by some single noosphere, but rather in ways in which modes of intelligence are identified in multiple scales and in multiple types, some ancient and some very new. These include mapping the extension and externalization of sensory perception, redefining computer science as an epistemological discipline, not only one of algorithmic operations, but indeed of computational planetary systems, comparing stochastic predictive processing in both neural networks and artificial intelligence and identifying their correspondences, embracing deep time of the planetary past and future as the foundation for a less anthropomorphic view of history, modeling life, both by the transduction of energy and the transmission of information, exploring substrate dependence and interdependence of general intelligence in all its forms, embracing, as you'll see in the first panel, of astronautics and space exploration as a philosophical pursuit, one that defines the limits of humanity's tethering to Earth and how it extends beyond. Exploring how astroimaging, such as Earth seen from space and distant cosmic events seen by Earth, has contributed to the planetary as model orientation. Theorizing simulations as epistemological technologies that allow for prediction, speculation, and ultimately a kind of synthetic phenomenology. Measuring evolutionary time in the complexity of material objects that surround us and constitute us. Finally, recomposing definitions of life, intelligence, and technology in light of what is revealed by the increasing artificialization and recombination of each. These modes of intelligence together lead us to construct a technological philosophy that might, hopefully in ways, synthesize into a path leading towards that viable planetarity, a capacity for complex intelligence to cohere and compose its own artificial future. So with that, let me introduce our panelists, whom I'm very grateful for joining us today and participating in the conversation. And then each of them will do a very short presentation of some of the work and the thinking that they've been doing in relationship to the Antikythera program, and then we'll really begin the open conversation to which we are all be able to listen in. First, Dava Newman, also our host here of MIT Media Lab, Space Science. Dava Newman is the Apollo Program Professor of Astronautics at MIT and a Harvard MIT Health Sciences and Technology faculty member. She also served as NASA Deputy Administrator from 2015 to 17. Her research in multidisciplinary aerospace biomedical engineering investigates human performance across the spectrum of gravity, including spacesuits, life support, and astronaut performance. Newman is the author of Interactive Aerospace Engineering and Design. To her left is Peter Galison of the Harvard Black Hole Initiative and professor of physics and history of science there. The central component of Peter's work involves the exploration of 20th century microphysics, atomic, nuclear, particle physics. He examines physics as a closely interconnected set of scientific subcultures, experimenters, instrument makers, and theorists. His many books include How Experiments End, Image and Logic, A Material Culture of Microphysics, Einstein's Clock and Poincaré's Maps, personal favorite of mine, and Objectivity with Lorraine Dostin. His latest feature film is Black Holes, The Edge of All We Know. To his left is my friend Nicolas de Monchaux, who is professor and head of architecture here at MIT. Until 2020, Nicolas was the professor of architecture and urban design and Craig's List distinguished chair in new media at UC Berkeley, where he also served as director of the Berkeley Center for New Media. De Monchaux is the author of Spacesuit, Fashioning Apollo from MIT Press, an architectural and urban history of the Apollo spacesuit. To his left is Xin Liu. Xin is artist in residence at the SETI Institute, an advisor for LACMA's Art and Tech Lab, a researcher at Antikythera, the founding arts curator in the Space Exploration Initiative here at MIT Media Lab, and a visiting fellow at Cornell Tech. She creates experiences and experiments that take measurements of our personal, social, and technological spaces in a post-metaphysical world between gravity and homeland, sorrow and the composition of tears, gene sequencing, and astrology. Recent institutional solo exhibitions include Seedings and Offsprings at Pioneer Works, At the End of Everything at ArtSpace. In 2024, she participated in Rhizome's flagship program, 7x7, and joined the Chao Center for Asian Studies at Rice University. She was the first artist in residence at the Houston Asian American Archive. And then last is Katherine Hayles. Katherine Hayles is a literary critic, most notable for her contribution to the fields of literature and science, electronic literature, and American literature. She is a distinguished research professor at UCLA and the James Duke Professor Emerita from Duke University. Her many books in print include Postprint, Unthought, The Power of the Cognitive Non-Conscious, How We Think Digital Media and Contemporary Technologies, and a book of deep influence on our program, How We Became Posthuman. So with that, it's my pleasure to welcome you here and to the conversation with this. So again, I'd like to keep this rather open, and so I'll sort of begin with a few kind of questions around this, and then by all means, please just jump in. But before we do, I want to give everyone, each of you, the opportunity to tell us a little bit about what you think. So please, David, take it away. Yeah.
Thank you very much. Let's see. So welcome to the Media Lab. I'm the director of the Media Lab, and we're just thrilled to have you all join us, and for the whole week. As Benjamin said, it's amazing. Thank you for your great lecture. So in all of exploration, there's three fundamental questions. Are we alone? Are there other habitable planets? And is there life elsewhere? The evidence is mounting. In the 10 seconds, you're seeing this beautiful Hubble image. 3,000 new stars were formed. We pointed Hubble at a very dark space in the sky. So it's cosmic fireworks. It's celestial birthplace of potential life and of all of these planets. So again, in exploration, all the exploration that we do, we're looking for life elsewhere. We will become interplanetary, and that tells us a lot about life here. So definitely planetary and interplanetary quest. What I'm showing you here from Hubble is an optical telescope. It's been amazing, working for 3 decades, and now we're flying our James Webb Space Telescope. It's amazing. It's in the infrared, and the same pillars of creation that you see here. Look at what we can unveil. We're looking in and seeing what was previously invisible. Now it's visible to us. So in these pillars of creation. Plus, engineering-wise and technology, it's 18 articulating mirrors covered with beryllium. It's awesome. It's just amazing. It is the world's greatest telescope, and it's not just finding science and revealing science. It's having us ask new fundamental questions that we hadn't even previously thought of. New questions for exploration that we hadn't previously thought of. Okay, a little bit closer to home here. Since I'm very fascinated with the search for life and the search for life in planetary systems, we have ocean world missions. Now, Spaceship Earth, right in the middle. This is to scale, so I like this chart. My favorite planet, I should mention. But look at little Enceladus. I know it doesn't look like much, but it's awesome. It's spewing out hydrocarbons. out of its south pole. And then there's Europa. We just launched a mission, the Europa Clipper, to Europa, a moon of Jupiter. Those are heat maps, because these are icy worlds. They have a lot of ice, but they're water worlds. And when you search for life, a simple search for life, a carbon-based life, we say follow the water. So all of these wonderful moons right here in our solar system are great places to look for life. Zooming in a little bit more, Mars. Mars is one of my specialties. It's been a life goal to get humans to Mars. Why? To discover life, probably past life. Mars and Earth are sister planets, 4.5 billion years old each. And then something went wrong with Mars 3.5 billion years ago in terms of what went wrong. Well, it lost its dynamo, its electromagnetism. But we've been searching and exploring Mars for 50 years, but not with humans yet. That first human mission will probably surpass 5 decades of exploration. MOXIE is the MIT experiment on the right that you see. We made oxygen on the surface of another planet. So it's an in situ research. We made oxygen for the first time ever on a planet, another planetary body. We took the carbon dioxide atmosphere, we split out those carbon atoms, and we recombined the elemental oxygen to get oxygen. Now, you might think it's to keep yourself alive. That's secondary. First is to provide fuel. Because when we send our humans to Mars, it's round trip, and we'd like to make sure that your fuel depots are there on Mars to get you home. And I think if the audio files are working, just thought a little treat for you, again, real quickly here would be to hear some sounds from Mars. Always bring cameras. We have 32 cameras on the Perseverance rover, and always bring a microphone to give people the experience. So let's see. We use a lot of augmented reality, virtual reality to do our daily science telecons, because of course we're not on Mars, but we think we're on Mars as scientists. We beam our avatars up and we decide what science we can do today. So here's the rover. That's a laser tapping. It's always windy on Mars, but listen how basic it sounds. Okay, now here's an audio file from Earth, and then I filtered it to Mars so you can see this difference living in this carbon dioxide atmosphere. And here's the same sound file now on Mars so you can experience that's what it'll sound like. That's very different when we get there and we explore and become interplanetary as a species. Okay, so now what's happening? Right here at the Media Lab and throughout MIT, we're going back to the moon. It's been 5 decades. We're going on commercial missions now, rovers and landers to get the data, the scientific data, to prepare for the future human missions that are coming up in just the next few years. So we're developing the tools, the lunar simulations, and here's a quick video of just our simulation of the lunar South Pole. We're going to Shackleton Crater. So we'll go to the South Pole of the moon. That's where the ice is. We want ice, H2O, water ice. So this is our current mission. We're hoping for end of January launch. Pretty exciting, just in a few months. Maybe the end of January we'll launch. This rover will go to the moon, and then our experiments that come out of the rover are a camera, a color and stereo depth camera on this little rover, as well as what we call the little astro ant, a little ant that rolls on top of the big rover to take thermal imaging and things like that. So please join us. We'd love everyone to join us in our kind of lunar mission control coming up in early 2025. Okay, just to wrap up shortly here, do specialize in keeping people alive and healthy on other bodies. Well, this is Apollo. I call this my lunar bloopers. We made it. We sent one scientist to the moon. That's Jack Schmitt, and boy, did we make his job hard. How's he supposed to do science if he's in? It's an engineering feat. The world's wonderful spacecraft, but we shrink it around to people. So our designs and how to think about how to do that differently then are to have a very form-fitting suit, not a big gas pressurized 160 kilogram suit, big, heavy, bulky is what we've done for 50 years. So here, again, at the Media Lab and across campus, we're really working and collaborating, again, with engineers, artists, architects, designers, to say, how can we actually put very advanced technology, this is a 3D seam knitted, a current prototype that we came up with. And it has sensing, it's very much a tight form fitting to pressurize someone, keep you alive, but to enable your exploration, to enable how you can perform on Mars or the moon. Okay, then I want to end my comments, my brief comments about what's all this for? What's all this space exploration for? I think it's very pertinent to the talk that we're having today. It's for the planet. It's for the planet. And so all of our learnings, I think, out, then really we need to reflect back on Earth, kind of this overview effect of Earth. And what do you care about? Well, we care a lot about Spaceship Earth. All of our systems, all of our living systems, I kind of call them the vital signs of Earth. All of our Earth satellites looking down on Earth to serve up the vital signs, the carbon dioxide, the greenhouse gases, the methane. What do you care about? Flooding or fire or the natural disasters. And so we put people, it's kind of a design tool for us, this immersive environments where you can see holistically the world, you can kind of curate it yourself to these dashboards, and then on this digital table you pop up your city because what you care about is where you live and where your family lives and where your loved one lives. And so giving people these types of tools, design tools for this type of experience. So I want to keep it there, and very, very glad to join the conversation. My pleasure.
Thank you.
So I work with colleagues, a worldwide collaboration on black holes, where we're not likely to find habitable environment. But it is Planetary, our study. To be able to image something in space, you want a big aperture, a big telescope, and to see our nearest and dearest black holes, one at the center of the Milky Way galaxy, Sagittarius A star, and one in the massive galaxy in the Virgo. Is M87 or Messier 87 star. You need to be able to have a huge telescope because it's like, in terms of angular spread on the sky, it's like an atom held at arm's length from our face. So to get the aperture size we need, you need to cover the Earth with telescopes. So the Event Horizon Telescope, a collaboration with more than 200 people in dozens of countries around the world, set up or used the already existing radio telescopes in many different places. 8 telescopes or arrays of telescopes on 6 sites. The fundamental unit of this kind of work is the baseline between telescopes. So right from the beginning, at a technical, rigorous, and inevitable level, is connections. No one country, no one telescope, no one observatory can function at all. It's meaningless unless it's connected to others. So what you're seeing in the left panel of the leftmost slide are the baselines as they come into view of the black hole of M87. And it's these combinations, these baselines, and then these triangles that are formed by them that allow you to create the virtual telescope, to fill it out. And that's what you're seeing in the middle panel of the left slide. As these different baselines come into view, you begin to see dots. And then as the Earth rotates, you begin to see them rotate and fill this out. So you're using not only the planet in its extent, in its size, but also in its rotation. It is an Earth instrument, not the Earth as object of inquiry, not mapping where the continents are. It's not mapping cosmic rays or magnetic fields or methane. It's using the Earth as part of the instrument itself to make heavenly observations. And then in the right panel of the left-hand slide, what you see is as the virtual telescope is filled up in the middle panel, you begin to see this image form, the one that is well known. It was first issued, we first saw it about a year before this, but it was a year of struggling mightily to make sure that it was not an artifact. The last thing in the universe we wanted was to show a picture and then have to retract it as an artifact. So in April of 2019, that image was released, and several billion people saw it in the first 48 hours. The middle panel illustrates something else, which is back in November of 1919, Albert Einstein's theory was first checked in a way that gave him a kind of world historical fame by Arthur Eddington, who saw that the starlight was bent as it went around the Earth on its way to us. But when around a black hole near the horizon, you could actually not only bend light, you could send it into orbit. And so what you're seeing in the middle slide here is light, in the first sense, just bent more than Eddington Einstein saw in 1919. But you can have more than that. You can have light that comes in and actually goes into orbit around the black hole. And so immediately after seeing the image on the left, the right-hand panel of the left-hand slide, we began to say, could we go deeper into that hot plasma, that hot billion-degree gas that orbits around the black hole near the horizon, and see this thin ring of orbiting light? That orbiting light tells you everything about the black hole. It's right near the horizon. Light in general relativity tracks out the straight lines, the geometry of space-time. And so what you're seeing as you begin to make an image of this is actually a trace of the dynamics of space-time itself. And this is a picture of the photon ring as it's envisaged in simulation in the middle slide against the background of direct light that's just bent somewhat by the black hole. You're seeing the geometry of space-time near an edge of the universe, which the horizon is. In a strict mathematical physical sense, the horizon is an edge of the universe. Anything that crosses over it has left us. On the right-hand slide, then, you see something else, which is what it would look like if we could make a movie, which is one of the things we'd like to do, by expanding the Event Horizon Telescope to not only have more telescopes on Earth, but to go into space to extend the virtual telescope, not to Earth size, but to 5 times Earth size and to be able to look inside that big, more blurry hot gas. And if you could see that, a movie would tell you immediately that you were looking at the photon ring, this thin ring of orbiting light, because it's fixed in space. It bears the imprint of the black hole, but it's not swirling gas. It doesn't have the dynamics of the things you would expect as hot gas orbited around the black hole. And so seeing something static on that ring that you see there that's not changing is the photon ring. You couldn't mistake it then for a tendril of orbiting gas. So that's the ambition. We have a mission, quite a number of us now around the world are working on a space mission, which we hope will fly in about 7 years, it's a proposed NASA mission to be able to see the photon ring. It's called the Black Hole Explorer. And that's then using an Earth-size and then a more than Earth-size telescope to see this. And if we could, and now I go into philosophy for a moment, the photon ring captures light from everywhere in the universe in a way that's not practical, but philosophically true. Each orbit of this infinite series of rings that are around the black hole captures all the light that's arrived there from anywhere. So it represents, if you were to imagine with the eyes of a cosmic lynx that you could peer into these rings sequentially, you'd see a movie of the history of the whole visible universe. And so in a sense, the black hole is watching us as we watch it. Thank you.
These are very tough acts to follow. So I'm going to thank the patients of Antikythera in a couple of ways. First of all, I'm going to speak and use this opportunity, or I have used this opportunity of this 5-minute talk to think through an essay that is overdue for the first issue of the Antikythera Journal, and I do so with humility, especially among such distinguished historians. I am part of a different long tradition, which is the architect as historical thinker and the designer as historical thinker. I work on designing structures, experiences, environments here on Earth. I was even a co-instructor of the space studio that was and is an amazing collaboration with the Media Lab and Aeroastro here at MIT, whose artifacts you see in the lobby of the Media Lab right now. But the essay, which I'm going to attempt to briefly describe to you, is an attempt, in this tradition to think through a kind of prehistory of a sort of global network of digital artifacts and simulation one of whose most important tasks, as Paul Edwards has written about, is in fact to simulate the Earth that it encompasses and help us understand the situation of the climate crisis and all that surrounds it. In a way, instead of tracing buildings, my own trajectory in this essay is to trace the historical and sometimes even literal mechanical connections between a set of objects that allow us to predate this global artifact of simulation back to the point when it could be identified in a series of objects, of interconnected historical and physical objects. And of course, it's just one trajectory through that history, and many others are possible. But mine starts, as many stories do, here at MIT. And is in the steps of our colleague David Mindell, who's shown that the story of cybernetics is not really the story of a book that then had a lot of influence, although it is that. It's actually the prehistory of a milieu of physical artifacts that created the environment or created the need for such a theory. In this case, in a very literal way, Warren Weaver, who first supervised the interconnection between artillery and radar that inspired cybernetics, had concluded that project successfully. It was off shooting down rockets above London by the time he even had his first conversation with Norbert Wiener, who, for propaganda reasons, needed to be utilized in the Second World War, and they gave him something to do, and it turned into an unexpected and very influential bestseller. It's also a story that I think, interestingly, particularly for me, encompasses a kind of three different kinds of history. The history of objects that simulate, the history of urban simulation, of thinking about the city as an object complex enough that we may want to know it in ways before we see it or create it. And as the title of the essay also says, it uniquely encompasses the space between worlds, not just the real and the virtual, but the space between worlds that Milton was the first to coin as encompassing the heavens as well. And so in the trajectory of the essay, we have first the self-synchronizing motors of the radar and artillery directors that inspired both Wiener and the kind of this milieu. We have the development of at MIT of novel theories of urban perception by Georgi Kepes, and not coincidentally the recently decommissioned Army officer Kevin Lynch, including speculation about novel graphic techniques to map images or create images of the city that would record new kinds of technological movement through it. The use of literally the very same motors that connected the radar unit and M9 artillery director by a young technician, Douglas Trumbull, to create graphic animations using surplus radar supplies in LA in the 1950s, and the eventual use of this expertise to create the slow and steady movement, the only movement that was actually possible technically of the spaceships of 2001, connected to, of course, the history of airplane trainers and ultimately modern real-time computing out of them. The need, as also documented by David Mindell, to create effective simulations for Apollo astronauts who could not otherwise be trained to land on the moon, before they got there. The adaptation, in turn, by the largest television network in the world at the time, CBS, of those simulation mechanisms to make up for the very inadequate visuals that NASA was at the time offering. It's learned to do better since then, but the inspiration in those simulations by CBS on a producer of the CBS lunar broadcast, Peter Hyams, to produce a screenplay about a faked Mars landing that was only greenlit after Watergate, but which would lead in part to the fact that about 6% 90% of Americans today believe the lunar landing was faked. The collapse of aerospace funding after Apollo and under the burden of the Vietnam War, leading to a very temporary but significant investment of aerospace dollars in that other momentary national priority of the problem of the city. The connection between that increase in funding to the use of the lunar landing simulator in the University of California to study modernist proposals for downtown LA, and then on the Berkeley campus, the use by the study by Kevin Lynch's protege and co-author on the sequel to The Image of the City, The View from the Road, on automotive perception in the landscape of Marin that is actually depicted in the slide in front of you. And this involved hiring Douglas Trumbull's protege, John Dykstra, who had been the effects director on Trumbull's directorial debut of Silent Running, which you haven't necessarily heard of because it was a commercial failure, but it was a technical success and contained new innovations in camera control, which in turn led to John Dykstra using a machine descended from an aircraft simulator, a digital mini computer developed here at MIT, to create a highly novel process for graphically simulating this landscape of Marin County, which then in turn led to the hiring of Dykstra by George Lucas in 1974 as the only effects specialist who could reproduce an 8-minute reel of the same World War II dogfights that had inspired the artillery director to begin with, which he wanted to use as the narrative core of a film then called Adventures of the Star Killer, but which we now know as Star Wars, which in turn was connected to the early success of Industrial Light and Magic, founded by Dykstra to produce these effects, and its ultimate split in 2006 into two firms. One based on the innovations in model-built animations and computer camera controls that could trick the eye, in fact, into creating vast illusory amounts of detail, and another firm devoted to the then new technology of, in fact, rendering vast amounts of detail in digital virtual environments. The former company was bankrupt by 2011, and the latter techniques, of course, now are increasingly indistinguishable from a singular narrative and this rather like the global environment of simulation which Edwards and others have recounted. Where does this leave us? It is a question under consideration by me, but amongst other things, it leaves us in Boston, whose dendritic structures had a unique influence of its own on theories of urban perception. Lynch spent 8 years studying Boston for The Image of the City and 2 to 3 months each on the two other cities that are in the book. So it is a kind of illusory symmetry between the three, and Boston is, of course, very unique in its structure here, and it leaves us also at a moment when simulations of ourselves, as Benjamin spoke about on Wednesday night, occupy a kind of shadow city whose effects on the urban landscape and ecology we're only beginning to understand. And it leaves us finally with one of the truisms of both factual space exploration and its science fiction siblings, which is we go into the space between worlds, not just to find what is there, but more than often to find ourselves as well. So, thank you.
It sounds like a conspiracy theory, but it's not.
Wow, thank you for the time warping journey. I'm Xin Liu. It's really exciting and intimidating to be here because I'm an alumni of the Media Lab. So right now I'm sitting among all my professors. I want to share a bit about my practice as an artist and engineer. In June 1965, NASA astronaut Ed White stepped out of his space shuttle and walked in space for the first time. Out in the vastness, he was tethered to the space station, as if a child attached to the mother through the umbilical cord, a new beginning for humankind. When I first had that experience with my own body inside the parabolic flight, thanks to the Space Exploration Initiative at MIT Media Lab, I did not fly. What happened was that the ground beneath me fell. The truth is, gravity never disappears. It is just everything falling together and the habit we live in reference to each other. So what if progress isn't upwards but back down? If the organic body we carry isn't meant for the space beyond, what shall we become? Carried by this crystal robotic sculpture, a wisdom tooth departs. The wisdom tooth's passage into space is a newborn entering another world, its body enclosed in a hand-sculpted glass skin, and its life supported by an electromagnetic system. I'll say it's the skin, the blood, the bone, and the spirit. Here's a moment of it floating in zero gravity, 100 kilometers above the Earth. As I birthed this creature in this new world, I was left behind. But perhaps every time when we leave home, part of us has to shed. Anyone who has ever immigrated into another country probably know what I'm saying here. And I want to know what is left behind. Back in 2018, I encountered this news article reporting local farmers in dire economic situations often use secondhand rocket metal to make farming tools. The image you see here, the middle one and the left, the little white dots are actually thousands of butterflies flying in the valley. I thought it was a science fiction movie shot, but it was actually a news article. So I want to see the moment of the terrestrial death of an extraterrestrial object, and that started my journey as a rocket hunter. Since the 1960s, hundreds of pieces of satellites, modules of space station, cargo spacecraft, and transfer vehicles of various shapes and forms and from most Western countries have regularly fallen into the southern Pacific Ocean. Point Nemo, it is the farthest geopoint from any landmass. It is a bit challenging for me to get here. However, in China, due to historical reasons, its original rocket launch facility was built very much inland. It's called Zhouquan. It's so inland that the first and second stages of the rocket simply cannot reach the ocean before they fell back on the ground. So I spent 2 years kind of scrapping local newspapers, reading archive documents from the libraries, trying to know whether I can find or match every single public launch information to like a falling incident that I identify as a subsequent event. And only in 2021, I got a filming grant, which I convinced someone to allow me take a team and set foot in the south and northwest of China to hunt for rockets. And it was 3 months of filming and hunting until the last 2 weeks we were able to find 2 rockets. One in the desert of Gansu, Dunhuang, and one inside the valley in Guizhou. And I believe in sharing secrets. So while the hunt for debris goes on, I was in touch with a private space company in China throughout the 3 years, and finally convinced them, or like annoyed them enough that they decided to donate one of their debris to my exhibition. It still surprises me that how this like half-inch thick metal became so soft and malleable like fabric, as you see right here, after it heats up during the re-entry and hit the ground at the moment. Although this debris has been stripped of any technological components and is just raw materials, as you see here, it was still classified as like supplies to weapons and cannot be exported out. However, during the process of, kind of acid wash this metal through the official documents of donation and creating artworks out of the waste metal, these artifacts have now been called art, and is actually outside China right now in Los Angeles, part of it, at the Bratton Museum of Art for exhibition. And lastly, I want to share a project that's very close to my heart, because since I think entering my 30s, I've been battling with the thought that my body inhabits the humanity's desire to sustain and perpetuate its species. So this series begins with my fascination with cryogenics as a sci-fi narrative device that often allows protagonists, if I say like a dude, lives through eons. Yet only upon reaching my own reproductive age did I have the epiphany that the manipulation of time is very much the same technology between cryogenics and egg freezing. They are solutions of time, or at least for time that is not worth spending until it's valuable and productive. The tyranny of the future is taking over the now. So as I was creating those works, I wanted it to be actually frozen. Maybe go to the slides before that you can see the mouse that is actually casted off my own mouse as a bronze and embedded a cooling system right behind it that causes a thin layer of frost to appear on its surface, right on this side. So once a friend of mine, also alumni from Media Lab, who was pregnant at the time, told me that her rib cage was opening because the hormones causes women's muscle and bones become softer and more stretchy during pregnancy in order to make space for the child. So maybe the last sentence I would like to say that I really feel sometimes our body opens, stretch, and became the void itself. Thank you.
Well, I'm delighted to be here on the panel and hear so many exciting things about outer space. I'm a sort of transition person who is moving from outer space into inner space, and in that sense, perhaps preparing for the next panel to come. So the kind of inner space that I'm particularly interested in thinking about is the space of cognition on the planet Earth. And so why am I interested in cognition specifically? Because I think that anthropocentrism is one of the forces driving this planet into unprecedented crises. So anthropomorphism, that is thinking with human brains and seeing with human eyes, is inevitable, but anthropocentrism, placing the human at the center of our thoughts and our ideas, is by no means inevitable and should be contested. So if you're interested in contesting anthropocentrism, cognition becomes central. Humans aren't the fastest creatures on the earth, we aren't the strongest, we aren't the biggest, but we congratulate ourselves that our cognition is so superior that we can build machines that will outpace every other species on the earth. So to begin then thinking about cognition in these terms is to envision it not as a human capacity, but as a biological capacity. And it's my assertion that every species on this planet has some cognitive capabilities. So to make that argument, of course, I had to come up with a definition of cognition. And I was looking for something that had a low threshold to count as cognitive, but could scale up to something as complex as human sensibility. So the definition I came up with was this: a process of interpreting information in contexts that connect it with meaning. Now, there are a lot of loaded words in that sentence: meaning, context, interpretation. But in the way that I parse those loaded words, every species creates meaning for itself through its interpretation of environmental information. What does meaning mean in that context? Basically, it means the ability to continue its existence. So every organism on Earth, every living organism, will strive to continue its existence. And in that sense, it has cognitive capabilities that can interpret information from the environment in terms that are meaningful to it. So in this sense, meaning becomes a species-specific attribute. That's one way to break that sense that only humans can create meaning. In this view, every organism creates meaning for itself. And it does so through the capacities that create a world for it, or in Jakob von Uexküll's terminology, an Umwelt, a world surround or a world horizon. So these are some of the ideas that I worked out in my forthcoming book called Bacteria to AI. But I was also interested in extending the notion of cognition to synthetic systems as well, specifically computational media and AI. And in the article that I'll be contributing to Antikythera, I go on to expand 5 criteria for something to count as a cognitive system. And it's specified by the acronym SIRAL, S-I-R-A-L, sensing, interpreting, responding, anticipating, and learning. And I test the criteria against minimal systems, minimally cognitive systems such as plants and bacteria, where I am able to show that it does distinguish between cognition and something like automatic adaptation or homeostatic systems. And then I use it to discuss cognition in terms of large language models. The main difference that appears in that analysis is that large language models don't have ability to sense their physical environments, rather they sense what one might call their conceptual environments, the constructions and representations that they make from human-authored texts. And then finally, I have fun comparing what an LLM makes of a human-authored text, Henry James' novella Figure in the Carpet, compared to what I, as a human critic, make of that same thing. Thank you.
Thank you all. I think you beginning to get a little bit of sense of the intricate carpet of the discourse we sort of build here. I have several thoughts, more than we can possibly get to, I think, in the course of this, to try to set this up. But instead of sort of going one by one, I'm going to sort of throw out 3 prompts around this as well, because I think it may be what I'm interested in is sort of the interrelations between them, and then I'm just going to throw it open to all of you and like just speak whenever you like, just a conversation. So one, sort of at the beginning, is this question of making meaning, and the capacity of making meaning in the relationship with it. I think one of the ways in which I think is clear from the discussion in many ways is thinking through the planetary and thinking of ourselves in relation to the planetary is increasingly the important way in which we try to establish not only a scientific predicament, but to make meaning of what we here are doing here. Which obviously has sort of a lot of significance. Nicholas, you didn't talk about the book you wrote on spacesuits. One of the other things that sort of we see across these is I was taken by this phrase that you used, like when we're making suit, we shrink the world around the person. And I thought, okay, that's it, that's the line. Like, shrinking the world around the person. There's ways in which perhaps we may have thought of the astronaut, the figure of the astronaut during the Apollo era, as a kind of exceptional figure. But it seems like one of the differences between that era and this era is that in many ways that figure of the astronaut, of a kind of fragile fetus-like body tethered to a technical environment, isn't something different. That's us. As the saying goes, ladies and gentlemen, we are in space right now. That the astronaut has a kind of generic figure, a kind of Vitruvian figure in some way, but precisely because it's so dependent on these other kinds of dynamics of this one. This may be perhaps one of the ways in which we are finding meaning. Another one had to do with the question of life and finding life. couple of weeks ago, I had the pleasure of visiting Stuart Brand, who was telling me about when he was at JPL when the Viking mission landed on Mars. He was standing next to Carl Sagan, and he asked Sagan, do you think there's life on Mars? And he turned around and said, well, there is now. And he said, in a way, that we're already an interplanetary species in this way if you count the technosphere as part of the Earthlings around this world. But I guess the question maybe around the meaning and the philosophical and existential meaning of astrobiology and finding existential life, and indeed of understanding us as astrobiology, we are astrobiology right here, has to do with this question of aloneness, right? And to the extent to what Sagan thought with the solar system was teeming with life, and all we need to do is sort of pick up the phone. The rare Earth hypothesis seems to be becoming more, perhaps more central, and it's the aloneness that may be really what we are facing, which may have equally profound implications for how we would think through this. So lastly, and then I sort of throw it open, what's also striking to me is the importance of the extraplanetary in the defining and conceiving of the planetary itself, whether that's the Frank White and the overview effect, that literally the discovery of Earth through movement into space, that Earth was the planet that was been discovered, the dependency of climate science, climate science is space science, one way or another. But that boundary, it seems, perhaps between the planetary and the extraplanetary now feels less strict. Like it's less of a sort of inside-outside and more of a kind of gradient dynamic. And the Earth as an open system that is defined not only as a kind of encapsulated blue marble, but as as part of a larger astronomic economy and dynamic. So anyway, these are some of the themes I sort of find of this as well, and I would just invite any thoughts or responses to this, or anything else you'd like to discuss.
I mean, I can, in some ways, I think David should also answer the question about the astronaut. I think it is, the spacewalking astronaut or cosmonaut. With the first, Alexei Leonov was, of course, the first person to float above the Earth in a kind of in a way that was mediated only by something that we could call clothing, right? Even if of a very special kind, and that relates to I think a really interesting point that one can make, and actually Paul Edwards refers to it, and Dennis Cosgrove as well, is that the Earthrise photograph, the first color one, and then of course the whole Earth photograph, which was a kind of mediated, politically mediated reality that was created at the end of the Apollo era, because you had to fly a special trajectory to get an unshadowed Earth in the frame. These were very unique moments in the history of Earth's awareness of itself, not just because we could see the whole Earth for the first time in a way that we're now weirdly used to, but because, as Edwards points out, it was a moment of historical singularity in its own way, because it was like the last time we transported a single technological artifact like the Hasselblad camera that was used by the astronaut to such a position that single lens and frame and exposure plate could capture the whole planet, on its, and that was a very, very special moment. And then increasingly, as our technological systems became more interconnected, as is like the underlying dependencies of the work that Peter showed as well, we can see more and more and more of the Earth, but it's less and less possible to identify a single mechanism that allows us to do so, or a single artifact, or a single kind of shutter or frame. And so that's a kind of an inflection point of which that single image is a kind of really interesting pivot. And imagining a whole planet has a very interesting history in special effects terms as well, because it was Douglas Trumbull's attempts in a film that Graphic Arts made for the World's Fair in 1964 that first brought him to Kubrick's attention. It's a very difficult thing to do, to try and depict a whole planet. So they had a whole system with like oil and et cetera, et cetera. And then, the Trumbull built 3 mechanisms for, and I have to also credit my colleague Carolyn Jones, who worked with me to bring Douglas Trumbull to MIT actually shortly before he passed away, and give us a chance to kind of really unpack this all with him. But there were three mechanisms that he famously built, each of which had in its own way the idea of the depiction of a whole world. One was the mechanism that allowed the depiction of the Discovery spaceship, which is sort of best known for, in which the actual giant model of the spaceship had 60-foot foundations into the bedrock of Slough in East London, and then the camera moved slowly past it to give you the sense of the motion. And the second mechanism was famously the slit scan technique, which sort of created psychedelically a transition with worlds. But the much lesser known of these three is something that was called the Jupiter machine, which took a single piece of steel with a white painted edge and projected light on it as it slowly orbited, as it slowly turned in circles, which allowed the creation of Jupiter and Europa and the Earth and all the planets that were actually depicted in the film. So it was only this kind of play of light on an edge as it was cast around in space that gave, like just before we could photograph these things, that gave a kind of an appropriate sense of a whole world. So seeing the whole world is a kind of, has always been a very important ambition of both technology and the kind of placement of human beings in the world. And of how we do it is a very important thread in the story.
And cosmology more generally, and the kind of cosmograph of this as well, right? And totality, trying to think of a totality. But I think he threw it to you on the astronautics.
I'll take the ball. Sure, a few things to say. So again, just an astronaut, and I said, kind of the engineering marvel, because if you shrink all of the life support systems, is the point I want to make, is all of your life support systems, as you mentioned, because we are dependent. I mean, you need your oxygen to breathe and your carbon dioxide, and so we are in this precious, precious planet. Life worked out pretty well for us here. And so if as we explore and we go beyond, you always have to think about, we want to keep humans alive, we want to keep living beings alive. So kind of all of those systems that we are dependent on. And I wanted to then flip that to all of Earth's systems. And I think of Earth in the different subsystems, specifically with a big focus on the oceans. We think about living in balance, and being in balance with our resources and nature, then think about the oceans, because that's, I think, where the urgency in terms of for climate and planetary survival and life support systems. As all of our exploring, we're just kind of seeing how is, could life exist? Yes, it's probably teeming with life. But I have Venus. Venus is a runaway greenhouse gas system. It's not N of one, here planet, the spaceship Earth. We know what Venus is like. We know what Mars is like. Very, very rocky, kind of very dead, maybe fossilized life. And then come back to Earth systems with starting at the oceans, our oceans, until 95% of our Earth's oceans we haven't explored. We haven't monitored and mapped and measured. That's where life, for our life. And then on the land, of course, all of us and our urban environments, our rural environments. And then to the atmospheres, most people think about, planetary, atmospheric climate. But I would submit that space, low Earth orbit space, where most of our satellites are, is not so special anymore. It's very accessible. It's very democratized. We're sending up missions, daily. So getting to the moon and Mars, okay, that's deep space. But just people, thousands of people, this is millions of people living, and we are planetary-wise and species-wise moving out. So again, to low Earth orbit, we can look down on Earth. That's just an extension, I think, of life. Yeah, from low Earth orbit looking down. It's just the sphere. We take a look at the Earthrise, but now including low Earth orbit and people living and thriving and doing well. That's just the horizon that we're on.
Yeah, like I think I mentioned, like this, which is an interesting thing for a planet to do, to sprout this crust of sensors. So Peter, one of the things that, as I'm deeply fascinated and admiring of the Event Horizon project is, as you indicated, the way in which it turns the planet into a machine. That the planet sort of constructs itself in such a way that it becomes the sensory and cognitive mechanism in such a way. And I know that part of what as you mentioned, sort of the anticipation is to then also not just to make a machine as big as the planet itself, but actually further to extend beyond that in one way or another. Now, you're also a historian of science and technology. Is this a category of one? Like, how would one locate the planet that is a technology within the history of technology itself? What kind of machine is this? I also want to ask you about Brand, which is another thing, but please, about Stuart Brand and the blue marble, but please, yeah.
Well, I think we've been launching satellites for a long time, and ones that go much further, like the James Webb Telescope that goes to L2, which is 1 million miles away. But I think what's distinct here is that these things are only meaningful in their connectivity. It's not just that they send back data, it's that the data itself, even if you had it from the satellite, would be nothing without all of the other telescopes. So that I think is an interesting, and in a way makes this one machine as opposed to a collection of machines. So that seems to me interesting. I think there's going to be lots of other future ways in which that kind of the interferometric connection among devices will be very important. Another thing that struck me in the talks was the way technology, or space technology in particular, has this dual aspect. There's a kind of visionary, bringing the future to us, which in a very inspiring way, Dava showed us these images of what has been and what will be our presence on the moon and on Mars and the flybys of the moons of Jupiter and so on. And there the technology seems so integrated to us, and drawing the spacesuits closer and less awkward. And at the same time, there's the technology as it falls back down to us or is captured in remnants. And Xin Liu's looking for these remnants of spacecraft that have crashed or left over or surplus, and Nicholas has done things with space gloves, and when the technology is without us, when it's just broken or left over or an artifact, when it's a historical technology, it seems so fragile. Such a delicate perch, such an artifact of what almost feels like the deep past, even if these suits are from these are not from the Stone Age, but I think having these, that the spacesuit can both look like the future and the past, both look empowering and future-oriented and fragile and cascaded down, seems to me a kind of beautiful juxtaposition that space is both our past and our future, and that seems, just hearing these together was very striking to me. I think the relationship of certain kinds of images which attain a kind of fascination to us, a kind of iconic quality that certainly Earthrise has over many decades now, and Stuart Brand has of course done much to help us understand what it means to have a grasp of a synoptic view of us and our planet, and there is something about the black hole. One of the things was fascinating in that interregnum between us, we first seeing the image, maybe 10 months before it was released, and its wide distribution, is that even people who had been simulating this for a long time, for years and years, and the images that that came out of these simulations, they're called general relativistic magnetohydrodynamic images, were stunned by seeing the real one, to the actual image. You could say, well, is it real? Is it artificial color? It's infrared. It's a shadow. It's a computational image, but so are the images on our cell phones. So I think that one thing that's striking was that at that point people said, that's the black hole. There's a black hole. And that kind of ostensive terror of being able to say that, as opposed to this is what a black hole would look like, was really striking. One of my colleagues, said she carried around her. The biggest miracle of the whole thing was that 200 plus physicists kept their mouths shut for 10 months. I mean, it's like we love to talk. That's why we went into the field. We want to find things and tell people about it, but it didn't leak. So until it was distributed on April 10th at 9:07 a.m. Around the world on different sites. So, but that idea that there's something haunting about and fragile about the Earthrise, and the similar NASA images from the 60s and 70s, and something terrifying about looking at a black hole. That's a black hole bigger than our solar system, that is an edge of everything we can know, and that it's not just that we know from the beautiful LIGO experiments through gravity waves that they're black holes, but there's actually, you can see it, and there it is. I think that was a different kind of fragility that it pointed to, a repositioning of us in the world, not just as a planet suspended in space, but as extraordinary things in the universe that were vast, tiny on the sky maybe in its image, but huge in extent and surprising. These objects that are the darkest objects and the brightest objects, the simplest objects, the most complex objects, the biggest objects that are compact and yet unknowable in some way to us. I think that sense of object but not an object. You can fall through the horizon and not know you're falling through. That could be these. It really is an object of paradox.
It's also in the best. I mean this in a good way. I mean this in a good way. It's also very frightening.
Yes.
In this way. I mean, it's an image of the abyss.
Yes.
And not in a. I mean, there's a link in my mind to the Xin Liu's discussion of falling, and space as a kind of falling. This is an inhabitation of a kind of abyss, and a physical, corporeal recognition of this abyss is not only the space into which we fall, but the space that makes us.
Yeah, there is a really beautiful essay by Hayles about it's a thought experiment on free fall, and she really talked about how falling is a form of freedom and disruption, and deterioration is a way of love, and loving inside of that that terrifying freedom. I think during and after pandemic, that's very much how I felt in order to find a sense of reference and structure in a society. And it is just really kind of like a philosophical moment when I first tried the parabolic flight, that I realized the only way that I can become this version of superhuman image flying is by falling with the world. But I really want to tag along Peter's comments on the image, because I only have 5 minutes, so there's a project I couldn't share. I've been really fascinated about debris, as you probably can already tell, and among which the NOAA satellites launched in the 90s for weather monitoring has been one of my favorites. They are decommissioned only 2 years after they were launched, but they're still functioning at the moment, and kind of frequently used by schools as education to help the student understand how satellite transmitting data, etc., because they literally scan through the Earth, taking pictures, and then broadcasting the data back. And you can use a broomstick with 2 wires and intercept that data in your own apartment, which I did with my partner Gershon, who's sitting here, during the pandemic. And it was really fascinating, because what you're saying about the kind of technologies that are kind of seemingly trapped in time, because those satellites, they were launched in the 90s, and then they literally had no one got up there and upgrade their hardware or firmware. So it was so trapped, even though the encryption back then was probably the state of art. But fast forward till now, it became something you can just use the Raspberry Pi and easily, debug it with something you can buy on Amazon. So it became accessible as a very big infrastructure, like having this little leak because it was trapped in time. And I found that quite fascinating. And then through that journey of literally a hacker amateur activity, I got very interested in orbital photography. And when we talk about blue marble, especially the one that we often associate with, not the one that the Apollo astronauts took, but the high fidelity version that was released in 2012, it was not the actual picture, it was a composition. it was actually lots of satellites that are taking pictures in low orbit, and then later kind of like a collage project and created a version of the Earth. And I found that incredibly fascinating because like that's kind of the aesthetic choice, but for objective nature, to convince the idea that we have an Earth that is look like that. Well, in fact, every single image in that composition is actually taken in different times. So it was like a time lapse of the Earth, but then composed all together to present the world. So maybe it kind of goes to you, because I've been thinking quite a lot about how the moment when we see the blue marble image, it kind of marks the beginning of Anthropocene, or the understanding that we're living here. It's almost like you have to leave and look back and realize, oh, I'm this, who I am. But I've been working on a new project, and there's one sentence I've been repeating in my own head is that seeing through the eyes of gods, have we mistaken ourselves for them? So that's something I've been quite struggling with in my practice, in terms of like how, as a human being crawling on the ground, yet having the visual capacity through all the technology and the infrastructures, I can see like a god, but I'm a person just on the ground. How can we deal with that cognitive and psychological disassociation or shift in our kind of physical, but also like technological positions? I don't know if it's...
Yeah, I was going to ask a similar question. I mean, you talk about the scales of biological cognition, but it's also, you've been very careful in the piece to sort of not separate this from the forms of cognition that we identify as technological, and to define these together. Yeah. I also just want to say is that we'll be having time for a little bit of Q&A, so think about your questions. Yeah.
Okay, just very quickly.
No,
then.
take your time. Take your time.
So if we were to try to write a communal history of anthropocentrism from, say, the Enlightenment to the present, it would, at bird's eye view, look something like this. That in the Enlightenment, there's a growing sense of individuality, of the individual person distinct from the community, distinct from the political body. That's sharpened by the rise of capitalism, and particularly here in America, it's sharpened with the idea of individuality, starting anew, not dependent on the old world for anything, and so on and so forth. And that really held sway until, I would say, roughly the last quarter of the 20th century. Then, largely because of our growing environmental crises, but also because of the rise of a new kind of biology, the idea of individuality began to give way to interdependencies. And one of the key figures there was Lynn Margulis, the now famous biologist, who argued that symbiosis and symbiogenesis was a primary driver of evolution on planet Earth. And she really highlighted the way in which every organism, including the human organism, is a multitude of other organisms. No person is really an individual in a biological sense. We have the biota within us. We have all the other ways in which we're interdependent with other organisms on Earth. So now we're here on the verge of going into space, and wonderful presentation by Dava about all the challenges that that introduces now. We have a deep embeddedness in Earth ecology, I think on levels that we haven't yet entirely realized. Psychological embeddedness, very complex physical embeddedness. So Dava mentioned, of course, oxygen, but what about the microbial embeddedness of humans in this environment? What happens if we lose or leave behind the environment that co-evolved with us and with which we co-evolved? So yes, we can take our technology into space and survive, but what about all of our interdependencies in other ways? So, looking at that image of the spacesuit that you were showing us, where you said the cord coming out is like the umbilical cord, it's tempting to think that the spacesuit is a kind of metaphor, a reintroduction of individuality, radical individuality. Now you have a new skin. Now you have a new technological skin that will enable you to leave your planet on which you evolved and go somewhere else. But that umbilical cord reminds us, as Dava pointed out, that in fact there's a whole complex interdependencies that makes that spacesuit work. And if you lose those interdependencies, then you're in a technologically fragile position, as Peter was mentioning.
Yeah.
So this idea that now we're sort of reintroducing a notion of individuality, I think is deeply flawed, that it has to be seen in correspondence with increasing interdependencies. And even the ability to mount something like a space mission, as we're going to do next year, requires all kinds of interdependencies, not only biological, but technological as well. So I just wonder what's going to happen with this image of ourselves as, how does Star Trek put it, boldly go where no man has gone before. How will that really work out, along with this increasing need to see the interdependencies here on Earth?
Yeah, I mean, to become interplanetary means to expand the interdependencies then, perhaps. But Nicholas, yeah.
So I mean, I think
else
there's
if
a
you'd like
very
to
fundamental
comment.
point, and I really, really appreciate the point that Catherine's trying to make. I think, so we're up here talking about two things, space and the Earth. And they both have they have an
We're
interesting
in space
relation.
right now, Nicholas.
Yeah, and the planetary. But, so the word space was coined by Milton, and he was influenced by Galileo and the technologies at the time that allowed us to perceive this. And he was trying to literally create the story of God and man. He for the very first time, with this invention of the space between worlds, which he was the first to capitalize, he put angels and the devil in the same place. He put them all outside the Earth in this kind of, and so that was what space was before it was anything else. And then in the early 20th century, the border between Earth and space was defined by a whole bunch of different scientific disciplines at different altitudes as the line which one needed a certain kind of technology to cross, or beyond which a certain kind of technology became necessary. And so lowest of all for biologists, because which is 37,000 feet, which is very low compared to everything else, where we need a pressure suit of some kind to survive. But and so space has always been where we kind of, a backdrop on which we cast both our hopes and fears about technology. Will it make us angels? Will it make us devils? Will we somehow become more than ourselves through the mediation of technology in that environment? But then there's a kind of wonderful inversion, which is that the major thing, if you talk to astronauts about, which I have a little bit, and Dava, I'm sure, and probably even Peter have much more, the main thing people who go into space talk to you about is the perspective it gives them on the Earth. And there's this word, there's the overview effect. Some of the first American, the Skylab 3 astronauts, when they came back, some of the very first Americans to spend significant amounts of time looking at the Earth in space, very underreported at the time, but they devoted all of their testimonies to Congress to the importance of ecological thinking and the kind of understanding of interdependency. And so there's this very interesting inversion between the view of humans onto Earth, not just onto space, which is often, as Peter said, not just what has been or what will be, or even what might be. We use it as a kind of tool to think about our relationship to technology over time, as well as a physical environment, and the actual attitude of people who've been there, who tend primarily to become more preoccupied with the interdependency of all the mechanisms that we have on Earth, which is a kind of like, in a way really reflects the logic of what she was trying to say. The last thing I wanted to say very quickly was that there's another image which belongs in the series potentially, which is the night lights image of the Earth, which was the product of a like side effect, unintended side effect of the nature of the sensor on the Landsat satellites, which were designed to photograph the Earth in daytime, but it turns out could pick up nighttime illumination, and therefore became one of the primary means we still have to study urbanization and the kind of transformation of the planet, which is belongs somewhere in there too, in the kind of square.
Strongly agree. I want to keep a little bit on time because a couple of us have to go. People have to go teach. If we have time, perhaps for a couple questions, give the audience an opportunity to weigh in. If possible, I think we have some microphones floating around.
Okay, I'll make a quick comment as we're waiting. Because it's maybe to the connectedness and going away from this individuality to the connectedness and the overview effect. Looking when something flips in your brain and you see holistic and you see the connections first. When you see the connections and that we're all in this together, rather than okay, I'm from this certain place, or rather than individuality or the specific. That's actually really, it is real. It happens to 100% of the astronauts that come back, so it's like, do we have to leave Earth to come back to appreciate our connectedness and appreciate, even the similarities and those dependencies that are kind of running, I think, through all of the comments from very different disciplines, but that symbiosis, that connectedness, and really putting a focus on that. So I'm hopeful. It makes me optimistic if we can move forward in that direction.
This is a little what I meant in my talk about the importance of allocentrism in both philosophy and technology, right? This sort of seeing from outside. All right, I think we have our microphones circulating. And do we have a question? A comment, please?
It works. Great.
Hello.
Thank you so much for the talk. It was quite interesting to hear all the different viewpoints. I would like to get your thoughts on certain things that I've always found disturbing. Is that usually new technology leads to war. For example, the airplane was just basically a bicycle with a small little leaf blower engine with wings in 1903. By 1910, it was dropping bombs. Same thing with a lot of different things. Every kind of technology pretty much first goes to war. Drones 15 years ago were just a toy. Now they're dropping bombs in Ukraine. So all this technology you're talking about, I don't really hear a lot about war and what it does in your plans. Also, having been a species that comes out of a colonized country from India, colonization isn't necessarily a good thing. And so there's all this talk about the colonization of Mars and so on. And for me, there's a difference between exploration and colonization. And I'm not really sure there's a reason for colonization. It's a good one. And perhaps could you explain why colonization is important? And there is talk about mining asteroids and things for profit. So nothing's going to be that easy. No, there's no free lunch, right? So I'd like to hear your thoughts on that.
So we have to keep it brisk.
So also, America loves manifest destiny. So don't want to forget that.
If anyone has a comment.
I'd jump in on the Mars because there's, at least from my perspective, there's no intent. I had no good reason that justifies colonization. So in exploration, we're going out very much for the scientific purposes to find life elsewhere and really teach us about that. So I think we run that experiment and it didn't work out very well for us on Earth. So I don't know any reason that we would want to colonize any other planets or anywhere else. So I think that, again, if we could learn from history, that would be a really poor course of action, and almost the same response quickly to war or weaponry. We have a choice. I mean, we develop the technologies, and we do get to choose how they're used. And I think it's really ethical imperative, a moral imperative, to have those discussions about how the technology is used. What's it built for? What's it designed for? And what's going to be the ultimate use of it?
Thank you. Any other? Yes, please.
Thank you so much for the panel, and it's such an intellectually stimulating conversation touch on so many topics. So I guess this question is not particularly for any speakers, but just from the one thing that's really fascinating to me is taking the picture of the black hole requires a coordination and synthesis of all the observatories across the globe. And kind of respond to the previous question as well, it's like the synthesis of the perspective of the global south, the global north, the west, and the east. And it almost illustrates this kind of possibility of unification of the current shattered infosphere and like the echo chambers that exist on the internet, and how like Einstein's general relativity illustrates like the frame of reference affects what you see. But however, I feel like among the talk, there seemed to be hinting at a planetary or cosmic perspective that is rather singular, and also like what Xin Liu had mentioned, it's like when we're seeing through the eye of God, do we mistaken us for them? But like the word them kind of implies a multitude of God or gods. So I guess I just want, I don't know how to frame this question, but it's more, I would like to hear more thoughts on this multiplicity of perspective and how a multitude of vision of the future can come together.
I invite anyone to jump in.
I'll take on the first half of the question. You know, we have international collaborations for a long time. Go back to mapping the heavens. There was a French-based but international collaboration called the Carte du Ciel, the map of the sky, and different observatories mapped different things and contributed, sometimes painfully, because they had to stop the programs that they were interested in pursuing in astronomy locally to conform to the agreements that had been hashed out at the international level. You have big collaborations like at CERN, much bigger than anything in astronomy now. The two big experiments at CERN now each have about 2,500 to 3,000 physicists and comparable numbers of engineers on them. So this is much, the Event Horizon Telescope has maybe 300 now, and that's big for astronomy. It's small for particle physics. But what I think is interesting about the distinction comes in a kind of governance structure. At CERN, there's a headquarters, and the headquarters, there's a director with a paneled office and a strong support from the European countries, especially, and others have contributed too. But that represented very consciously an effort to create a model for what they hoped would be a future European Union. I mean, this was a scientific collaboration that was supposed to be an exemplar about a kind of a science that was not about building bigger ballistic missiles with, nuclear warheads, but something else. And I think that there is a sense in which the Event Horizon Telescope is really odd in the sense that, if I could sort of riff on the old idea of Goethe and then Weber of elective affinities, it's a kind of collective affinity. Each of these countries is not paid, but there's no central organization. There is no headquarters. There's a director here and a chief scientist there, and many dozens of countries involved, and it only works through this kind of voluntary affiliation with this larger effort. So I think there is something hopeful in it, whether it's a model for, right now it seems like a doomed time to think about collective action among the global north, the global south, different countries, east and west. We are, a fierce rise of ultranationalism that seems to be pervading our political landscape. But it does seem to me a kind of hopeful gesture, even if a small one, even if only in the scientific and not very applicable domain of astronomy and black holes. But still, nonetheless, it seems to me we are always looking for models and alternative paths, and even if they're not at the scale of changing the registration that we have of of nationalism at this moment. Nonetheless, we have to be able to think otherwise if we're ever going to stop thinking the same.
Here. So I need to make sure we keep on schedule. I think ending with hope is always a good one, and I just say, clearly societies always evolve in relation to their cosmologies, and that's maybe what we see emerging here. We can continue the conversation in the lobby afterwards. Our next panel, where if this panel, we're sort of emphasizing the planetary side of Planetary Sapience, the next one emphasizes the Sapience one, and as Kate mentioned, our interest in the evolution of intelligence, the artificialization of intelligence, the history of Planetary Sapience, and more. So look forward to seeing you then. Thank you so much. Thank you so much. Thank you. It's so great. So great to have you.
Ready out in the foyer. Please stick around for the next panel, which will begin at 2:30. Thank you.